Okay, we're doing y equals the absolute value of 4x plus 1. So when we graph that without the absolute value signs, we have y equals negative 4x plus 1. So I draw it over 1. I go to my y-intercept, which is positive 1. And then I go down 4, right 1. 1, 2, 3, 4, right 1, because it's a positive 1. Down 4, 1, 2, 3, 4, right 1. Or I could go completely opposite. Now, why could I go completely opposite? Because I can move the negative down to the 1 and make the 4 positive. So that's why you can go completely opposite. So instead of down 4, right 1, because it's a positive 1, I could go up 4, 1, 2, 3, 4, left 1. And it actually lands on the same line. This is really messy. Okay, now, once again, it's not an accurate x-intercept, so I have to find the x-intercept. How do I find the x-intercept? I just put 0 in for y. So 0 equals negative 4x plus 1. Subtract my 1. Negative 1 equals 4x. Or negative 4x, sorry. Divide by negative 4. And x equals a quarter. So my x-intercept is at a quarter and 0. So my graph is going to turn on a quarter. Oh, that's funny, a quarter. That was funny. It's going to turn on a quarter, like turning on a dime, but turning on a quarter. It's Friday, people. It's Friday. Okay, so this, if x is less than a quarter, and another equation, if x is greater than or equal to a quarter. So when I find the absolute value of this, what stays? When I find the absolute value of that line, what stays? The left part, the part above, because when your y's are positive or 0, they're not changing. So those aren't changing. So what part of the graph? The graph to the left of a quarter is staying, or the graph to the right of a quarter is staying? To the left of a quarter is staying. So that means less than a quarter. So I'm going to rewrite this equation, the original one, negative 4x plus 1, to the left. Okay? Then this part down here gets reflected. So instead of it being at 1 and negative 3, it's going to be at 1 and positive 3. And wow, this is really terrible. But pretend that it's a better drawn graph than it is. Okay, so that part's going to reflect up. Now that part, that line is actually a whole line, is it not? The dashed part just doesn't exist because when x is less than a quarter, it follows this line, the green line. When x is greater than a quarter, it follows the red line, right? And the red line is just the green line negated. So it's going to be y equals negative 4x plus 1. So it's actually positive 4x minus 1. So it follows the equation positive 4x minus 1. Oops. When it's... Look. It would be negative 1 is the y-intercept. Yeah. Always put it through. Yeah. It wouldn't be wrong, but put it through. Negative 3x minus 5. Yeah. Yeah. Yeah.
How would you know when, like, it's this one or when it's this one? And how would you know when there's one?
You need to have both equations. You can't just have one. Like, you have to write it like that.
Oh.
Those are the two piecewise functions that make up that graph.
Okay, that's like the only part I don't get. You have to figure out.
Because if you look here, this one didn't change, right? This part didn't change, the green one. And the green one represents this equation. Shh. The green one represents this equation, right? And that's to the left of a quarter, is it not? So I put the green one when it says less than a quarter. And then the red one is the one that's reflected up. And because it's reflected up, I have a reflection in the x-axis, which we did in transformations way back when. So I'm going to distribute that negative in, and now it actually follows this red line, which is the negated version of it, when I'm on the right of a quarter. So I write it here. So these two pieces make up this V above this absolute value. This is this. This equation, these are the two piecewise functions, two pieces of a function that make up that equation. Okay? Yeah. One. Yeah. Okay. Let's try a quadratic. So, C. C out of the book is y equals the absolute value of negative x squared plus 1. You can go to your calculator and get the x-intercepts and the vertex for this one. Go there right now. I won't make you do it the actual algebra way right now. Go to your calculator and get me the x-intercepts and the vertex. And this graph is a maximum because it's concave down. Now, when we find the x-intercept and the vertex, we're going to just plug this into y1, correct? Not the absolute value. We're plugging the original in, and we're changing the original graph. So we're plugging the original in without the absolute value. The vertex, when I use my calculator, it says 6.6976 e to the negative 7. What I tell you when it has e to the negative anything, what is that the same as? 0. Because that just means it's 6.697 times 10 to the negative 7, which means it's 0 decimal, 6 zeros, 669, which you can round to 0. Okay? So look always to the right of your decimal, and if it says e to the negative something, that just means there's a whole bunch of zeros in front of it. Round it to 0. Okay? So this vertex is at 0 and 1. All right? And then the x-intercepts are at negative 1 and positive 1. And then I want a few points below. So a few other decimal or a few other numbers or coordinates are 2 and negative 3. And I want above negative 2 and negative 3. I want more points on either side so that I can draw the arms. I went to my table of values. Yeah. So I went second graph to my table of values, and I found these 2 points. Because what's going to happen is you're going to draw the parabola down like this, and you have to take those arms and draw them up, right? And we're not going to have any actual coordinates on the arms, so how do you redraw those? So, sketch our graph. So I'm plotting my vertex, 0 and 1. My coordinates are here and here. Now, like I said to you, if I just go freehand this now, do I actually have any points on the arms? No. So how do I take a point and keep the x and change the y's when I actually have no idea what those points are? So I went to second graph, and I went to my table of values, and I went on the left of negative 1. I pulled off a nice small point. I went on the right of positive 1. I went on the right of positive 1, and I picked a point, okay? So I put 2, negative 2, and negative 3. And then I went positive 2 and negative 3. And now I actually have points that I could make go up and draw the graph, right? Other than that, I would have just been like guessing. Okay. So we're actually going to get 3 pieces this time. We're going to get 3 pieces. We agree? So what part stays? What part doesn't change? The little part in the middle here, right? Because it's positive, because it's above. Now, paying attention. We're going to get 3 pieces this time. With a line, we got 2 because we got the V. Now we're going to get an arm, the little hump in the middle, and an arm, right? So we're going to get 3 pieces. So when we write the piecewise function, we're going to have a piece if x is less than -1, because less than -1 follows this arm, correct? We're going to have a piece between 1 and -1. That's the piece that stayed. So if -1 is less than or equal to x is less than or equal to 1. And then we're going to have a piece if x is greater than 1. I always put the equal signs on the middle piece. So we're going to get 3 pieces this time. Last time we got 2 pieces, right? This part of the V, this part of the V. We agree? Now we're going to get an arm, the middle, and an arm. Agreed? What part stayed the same? What part stayed the same? This little piece right here, correct? The value between when x was between -1 and 1. Okay? So this piece here, when x is between -1 and 1, that stayed the same, yes? What equation does that represent? -x squared plus 1. Do we agree? It follows the actual parabola, yes? Then what happened is these arms are going to reflect up. So instead of being at -2 and -3, there's going to be a -2 and 3. And +2 and 3. What is this actually representative of? It just doesn't include this. You don't draw this piece, right? The only piece that exists on the absolute value function is this. This, and this. This black would represent the absolute value, right? It's the weird looking W. Yeah? But this arm here and this arm here follow the concave up parabola, correct? Do you see the whole concave up parabola? I just don't draw this piece because between -1 and 1, it actually follows the concave down parabola, right? So these 2 outside pieces actually follow the concave up parabola, which is just the negation of this one. So this is going to be y equals -x squared plus 1, which is actually +x squared minus 1.
It is time for our closing blessing. Would you please rise?